kò sí wàhálà tó bá ti rẹ́dì mo ti rẹ́dì. Ok ṣé ó ti ní note ó ti ní but kí ló máa lò ṣáwọn ilé máa yá ń device wọn. Ah ọmọ mi ò connect dáadáa dáadáa kọ́ máa lè yá àtọ̀ kọ́ máa lè yá nítọ̀dọ̀ wọn. Tí mọ́ mi bá lè bá tọ́ bá lè yá nìkan. Kò sí wàhálà màá bá wọn sọ̀rọ̀ kò sí wàhálà màá bá wọn sọ̀rọ̀. Ok inshallah kò sí wàhálà sà ọlọ́run fi yé wọn kò sí wàhálà sà kò sí problem sà inshallah ọlọ́run fi yé wọn. Bẹ́ẹ̀ni kò sí problem sà kó ra note ẹyọ kan ti tó for now tó bá ti lò tán rà alright kò sí wàhálà bra kí lẹ rí sà ṣé ẹyọ kan ti tó for now tó bá dẹ̀ lò tán á tún ra mi. Sorry about that interruption. So let's practice drawing velocity time graph. Initially the was traveling at 200. Initially the train was traveling at 200, then it decelerated from 200 to what? To 0. So over a period of 20 seconds. I can decelerate it to 0 now because I have found my final velocity to be 0. This is the initial 200. So that's what the velocity time graph will look like. Let's continue. Let's continue with question 6. Question 6 now. Question 6 now. Excuse me. Question 6 says if a car starts from rest and moves with a uniform acceleration of 5 meters per second squared for 10 seconds, calculate the distance it covers in the last 1 second. Okay, a car starts from rest, so initial velocity was rest. Rest means 0 meters per second. Moves with an acceleration of 5 meters per second squared for how many seconds? 10 seconds. For 10 seconds. It says calculate the distance traveled in the last second. Now, distance traveled in the last second. Distance traveled in the last second. Distance traveled in the last second is equal to distance traveled for the whole 10 seconds minus distance traveled for the first 9 seconds. You'll be using this a lot, so try and get it. If something travels for 5 seconds and you want to find the distance traveled in the last second, the distance traveled in the last second will be equal to the distance traveled for 5 seconds minus distance traveled for the first 4 seconds. So we'll be doing this a lot, distance traveled in the last second. So let's now take it one after the other now. Let's take it one after the other. So distance traveled for 10 seconds. Let's find that first. Now, initial velocity is 0 meters per second. Final velocity, okay? Initial velocity is 0 meters per second. If we want the distance traveled for 10 seconds, our time traveled, or our duration of the journey will be 10 seconds. Then acceleration is 5 meters per second squared. So let's find distance traveled for 10 seconds. Using you find what formula connects S, U, A, and T. What equation of motion connects S, U, A, and T? It is S is equal to UT plus half AT squared. This will give us the distance traveled for 10 seconds. That's 0 times 10 plus what? Half times 5 times 10 squared. So put it together. 0 times 10 will disappear here. this one will disappear. It won't appear in the equation again. So that gives you what? That gives you half times 5 times 10 squared left. That's the distance traveled for 10 seconds. That's half times 5 times 100. Half times 5 times 100 is what? Half times what? 500. And that's what? 250 meters. The distance traveled for 10 seconds is 250 meters. Let's now go ahead and find the distance traveled for 9 seconds. Most of the values will still be the same. The initial velocity is 0 meters per second. The time taken will now be 9 seconds. We need the distance traveled for 9 seconds, so our time is 9 seconds. Then acceleration is 5 meters per second squared, and what? And distance, that's what we are looking for. So what formula? You now think, what formula connects U, T, A, and S? What formula connects U, S, A, and T? The formula that connects all four is S is UT plus half AT squared. So S will be 0 times 9. You understand? We are now looking for the distance traveled for 9 seconds, for the first 9 seconds. So that will give us 0 times 9 plus half times 5 times 9 squared. So the same way, I'll be left with half times 5 times 81, which is what? 205. You understand? 5 times 81 is okay. Let me try and do this correctly so I don't make mistake. 5 times 81 is 405. 5 times 81 is 405. So that's 405. I'm coming, and let me write it very neatly. So that's 405 over 2. 405 over 2 is what? 202.5 meters. So the distance traveled in the first 9 seconds is 202.5 meters. Therefore, distance traveled in the last 1 second, or the last second, which is S10, distance traveled for the whole 10 seconds minus distance traveled for the first 9 seconds, is equal to what? 250 meters minus 202.5 meters. And that's what? That's 47.5 meters. That's 47.5 meters distance traveled in the last second. Let's go to question 7. That ends question 6. Let's go to question 7. A body starts from rest. In question 7, a body starts from rest and moves with a uniform acceleration of 8 meters per second squared. What distance does it cover in the 6th second? It's the same thing as the last question. Distance traveled in the 6th second. Distance traveled in the 6th second will be, let me change the distance to SI unit of distance. Sorry, SI symbol of distance. Now, distance traveled in the 6th second will be equal to distance traveled for 6 seconds minus distance traveled for 5 seconds. Are you getting what I'm saying? Just like we did there. Distance traveled in the 10th second, distance traveled in the last second. The last second here was also the 10th second. The last second was the 10th second. So distance traveled in the 10th second was distance traveled for 10 seconds minus distance traveled for 9 seconds. So get the English right. I'll ask questions if you still need. So here it means distance traveled in the 6th second is equal to distance traveled for 6 seconds minus distance traveled for 5 seconds. So what does that give you? Okay, let's now take it one by one. We'll find distance traveled for 6 seconds. So initial velocity 0 meters per second. Then acceleration, what? 8 meters per second squared. Time now 6 seconds because we are looking for distance traveled for 6 seconds or distance traveled in 6 seconds. So distance unknown. So using what formula connects U, A, T, and S? The formula that connects U, A, T, and S is what? S is equal to UT plus half AT squared. So that will be what? 0 times 6 plus half times 8 times 6 squared. So this part will disappear because of the 0 times 6. Then what will we have left? We will have half times 8 times 36 left. That's 4 times 36. 4 times 36 is what? 144. So distance traveled for 6 seconds is 144 meters. Distance traveled for 6 seconds is 144 meters. Now, let's find distance traveled in the first 5 seconds. So let's now calculate the distance traveled in the first 5 seconds. This is the same thing. Initial velocity 0 meters per second. Time will now be 5 seconds. Acceleration is still the same, 8 meters per second squared. And we are looking for distance traveled in 5 seconds. We use the same formula that connects. We use the same formula connecting U, A, T, and S. So using S is UT plus half AT squared. My distance traveled for the first 5 seconds will be 0 times 5 plus what? 8, half AT squared. UT plus half AT squared, that's half times 8 times what? 5 squared. So let's do it. We'll be left with half times 8 times 25, and that's 4 times 25. 4 times 25 is 100 meters. So the distance traveled in the first 5 seconds will be 100 meters. So distance traveled that means distance traveled in the last second, which is also distance traveled in the 6th second, is equal to S6, distance traveled for 6 seconds, minus distance traveled for what? 5 seconds. So that gives us 144 meters minus 100 meters. And that's what? 44 meters. So distance traveled in the 6th second is 44 meters. Let me put second there. Distance traveled in the 6th second is what? 44 meters. That ends number question 7. Let's go to question 8. It says a body accelerates uniformly from rest at the rate of 5 meters per second squared for 12 seconds. Calculate the distance covered by the body during the acceleration. Okay, from rest means the initial velocity was what? 0 meters per second. It says the body accelerated at the rate of 5 meters per second squared for how many seconds? 12 seconds. And we should find the distance traveled during this acceleration. That's a simple question. Let's go ahead and draw a velocity time graph for the motion, just to learn velocity time graphing alongside. Time in seconds, velocity in what? Velocity in meters per second. So it says from rest, accelerates uniformly from rest. The body accelerates uniformly. From rest. For how many seconds? Let's put this down. For how many seconds? Use your ruler for this so it can be straight. For how many seconds? For what? For 12 seconds. The second here already, so I don't need to put the second. Then the rate of acceleration is the gradient of this graph, 5 meters per second squared. The question says we should find the distance traveled during this acceleration. So that's a simple question. What we need to do is, okay, I've written the parameters. We are looking for what? Distance. So now check very well. Inspect this. What formula connects, what equation of motion connects U, A, S, and T? Check your equations of linear motion. Which one connects U, A, S, and T? The one that connects U, A, S, and T is S is equal to UT plus half A T squared. And that's what 0 times 12 plus what? Half times 5 times 12 squared. So that gives us what? That gives us 0. This is 0, so I can just forget about this and just handle the second bracket. So I'll be left with half times 5 times 12 squared. And that's what? Half times 5 times 144. Half times 5 times 144. What does that give me? I'm trying to manage my space not to waste it. That's 5 times 144 over 2. And that's 5 times 72. That's 360 meters. The distance traveled during that motion is 360 meters. That's question 8. Question 9 now. Let's go to question 9. It says a particle starts from rest. It says a particle starts from rest and moves with a constant acceleration of 0.5 meters per second squared. So let's jot that down straight. Before I even write the parameters out, let me go straight to graphing. Time, seconds, velocity, meters per second. Starts from rest, moves with a constant acceleration of 0.5 meters per second squared. So this is rest here. Okay, let's get the remaining information in the question. It says calculate the distance. Calculate the distance. Is it distance? Okay, calculate the time taken by the particle. It's time. Calculate the time taken by the particle to cover a distance of 20 meters. Okay. In this case, there's a difference. Okay. Calculate. Here we now know what distance is covered. Distance covered is what? 20 meters. It says we should calculate the time taken. The time here taken to cover that distance of 20 meters. So let's go ahead and get our time. We write our parameters out as usual. Initial velocity was rest, which means the body started from 0 meters per second. Acceleration was 0.5 meters per second squared. Then acceleration was 0.5 meters per second squared. Then time taken, we don't know, but we know the distance traveled as what? 20 meters. So now, what formula connects the parameters we have in this motion are initial velocity, acceleration, time, and distance. What formula connects those four? Connects these four parameters of motion. U, A, T, and S. What formula connects them? It is still S is equal to UT plus half AT squared. So using S is equal to UT plus half AT squared, that means 20 meters. Since the distance traveled is 20 meters, is 0 times T plus half times 0.5 times T squared. That's UT. S is equal to UT plus half AT squared. So take note of them. What does that tell us? 20 is equal to, this one will disappear, 0 times T is 0. So I don't have any business with that bracket. All I have business with is 0, half times 0.5 times T squared. So let's put that together. What do we get? We'll get 20 over 1 20 over 1 is 0.5 t squared over 2. And I can cross multiply. When I cross multiply, 0.5 t times 1, 0.5 t squared times 1 will give me 0.5 t squared. Then 20 times 2. 20 times 2 is what? 40. 20 times 2 is 40. So 0.5 t squared is equal to 40. That gives me t squared is 40 over 0.5. T squared is 80. T is square root of 80. You press your calculator, you get the time taken in seconds. I can write in short form if I like. 80 is root 16 times 5. I hope you know how I got that. 2 in 80, 40. 2 in 40, 20. 2 in 20, 10. 2 in 10, 5. 5 in 5, 1. So I have 4 2's here. That's what? 16 times 5. If I put that together, what will I get? If I put that together, I'll get root 16 times 5. That gives me root 16 times root 5, and that's 4 root 5 seconds. So the time taken to attain a velocity of 20 meters by this body is 4 root 5 seconds. Let's go to number 10. Let's go to question 10. How far will a body travel in 15 seconds if it's uniformly accelerated from rest at 6 meters per second square? That's a simple question. Accelerated from rest means the initial velocity was what? Rest. Means the initial velocity was rest and the initial velocity was 0 meters per second. Okay? Acceleration 6 meters per second square, and it was accelerated for what time? 15 seconds. What distance will it travel? What distance will it travel? Check. What are the parameters we have here? U, A, T, and what? S. And we are looking for one of them, which is S. So what formula connects U, A, T, and S? Check your list of the equations of motion. Senior, can you see this? The equations of motion are V is U plus AT, the first one. Second one is U plus V over 2, which is average velocity times time, is equal to distance. Can you see that? Third one is UT plus half AT squared. And the last one is V squared is U squared plus 2AS. Which one of these equations connects only U, A, T, and S? It is this third one. That's how we choose the equation to use for any problem or any question on linear motion. S is UT plus half AT squared is the most suitable equation of linear motion to use in this case. So let's take that now and use it to answer the question. We are looking for S. So we say using S is UT plus half AT squared, UT plus half AT squared. S will be what? 0 times 15 plus half times 6 times what? 15 squared. So that gives 0. I don't even need to explain that anymore. I'll be left with S is half times 6 times 15 squared. Half times 6 is 3. So the distance traveled is 3 times 225. 15 squared is 225. 2 here 1, 2 here 3. So you have 3 times 225 left. I can help you write that here just so you don't get confused. 2 here 1, 2 here 3. So you are left with 3 times 15 squared. So that's 675. The distance traveled during the motion is 675 meters. Now check. Let's move on. Question 11 now. Question 11 now. Question 11 now. Question 11, what's there? A car takes off from rest and covers a distance of 120 meters on a straight road in 20 seconds. The question says, calculate the magnitude of its acceleration. Okay, a car starts from rest. That means the initial velocity was rest, which is 0 meters per second, and covers a distance of 120 meters in a time of 20 seconds, we need the acceleration. This is also a question involving S, U, A, and T. So we say using the most suitable equation of linear motion to use is S is equal to ut plus half a t squared. So distance 120 meters. Initial velocity, which is u, is what? 0. So I'll write 0 for it. Times time 20 seconds. Times time 20 seconds plus half times acceleration that we are looking for times time squared 20 seconds squared, half a t squared, half a t squared. Can you see that? So let's continue. This one will disappear. It will disappear. 0 times 20 is 0. So what do I get left? 120 is equal to half times 120 is equal to half times a times what? 20 squared. That's what I have left. So 120 over 1 is equal to half times a times what? 20 squared is 400. 2 in 400. 2 here 1. Let me try and write that one. This is 2. 2 here 1. 2 here 1. 2 here 200. So that gives me 200A. I hope you can see the division there. So that means 120 is what? 200A. 200A is 120. A, which is the acceleration, is 120 over 200. What's 120 over 200? 0 divides 0. What do you have? Okay. That's what? 3 over 5. And that's what? Acceleration is 0.6 meters per second square. The acceleration of the motion is 0.6 meters per second square. Question 12 now. Let's go to question 12. It's getting interesting. A bus travels at 25 meters per second. A bus traveling at 25 meters per second accelerates uniformly at 5 meters per second squared. What is the distance covered in 8 seconds? Okay, I've not been, drawing graph. I should be drawing graph all the time. Okay. I should be drawing the graph so we learn along how to draw velocity time graph. Okay. Can you see this now? Velocity in meters per second. Velocity is in what? Meters per second. The velocity is in meters per second and the time is in seconds. It says a bus traveling at 25 meters per second. Never mind that this looks like a 5. It's 25 meters per second. It says a bus traveling at 25 meters per second. So that means the initial velocity was 25 meters per second. Accelerates uniformly at 5 meters per second square. Accelerates uniformly at 5 meters per second square for a period of 8 seconds. So let's put that down and put 8 seconds. The acceleration took place for what? 8 seconds. So let me go ahead and put 8 here. The question says calculate the distance traveled. Calculate the distance traveled. This is simple. All we need to do, write our parameters. The initial velocity is not rest here. The initial velocity was 25 meters per second because it was initially traveling at 25 before the acceleration commenced. Can you see? It was traveling at 25, then it accelerated at 5 meters per second squared for a period of what? 8 seconds. So acceleration 5 meters per second squared. 5 meters per second squared. Time taken 8 seconds. So what are we looking for? Distance traveled. It's the same thing, just that the u here is not 0 because all that we have in this motion too is u, a, s, and t. It can take time to master, you get it. So using s is ut plus half a t squared. What do we get? Okay, let me try and separate this from my graph so that you don't get it mixed up. Using s is ut plus half a t squared. So we are looking for the distance traveled. The initial velocity is 25, time of acceleration 8 meters per second, 8 seconds, half times acceleration 5 times t squared, 8 squared. That gives me 200 plus what? Half times 5 times 8 times 8. So what's that going to give you? 200 plus, that's 5 times 4 times 8. So that's what. Don't ask me how I got 5 times 4 times 8. I actually did 2 year 1, 2 year 4. So I have 5 times 4 times 8 left. I hope you can see that now, seniors. So 5 times 4 times 8 left. That's what 200 plus 5 times 4, 20 times 8, 160. 200 plus 160, 360 meters. The distance traveled is 360 meters in this period. 360 meters. Now, in order not to, have to do that again, let's take that as a first method, because in this kind of case, we can use the area under the graph to calculate the distance traveled in that time. If you look at the shape of this velocity time graph well, it's a trapezium. The shape of this graph is a what? Trapezium. The two parallel sides are here. 25 and whatever the final velocity is here. So we can do that and use it to get our answer. Let's find the final velocity here, and let's use this as our b. Let's use this as our b in the two parallel sides. This one as our a, and this as the vertical height, 8 seconds exactly. But before we do that, let's find velocity. The value of v is the value of this b. Can you see that? So let's go ahead and find velocity. So let's say second method. Okay, it started from a velocity of 25 meters per second and accelerated at 5 meters per second squared for 8 seconds. So how do we get the final velocity? The equation we will use for that is u plus at. Final velocity v is what? U plus at, because that's the formula connecting a, u, t, and v. Can you see that? So final velocity will be 25 plus 5 times 8. What's 25 plus 5 times 8? That's 25 plus what? 40. So the final velocity attained, v, is 65 meters per second. So 65 meters per second will now be our b. Area, the distance traveled is the area under the trapezoidal graph, which is half a plus bh. So half times a is what? 25 meters per second. B is what? 65 meters per second. Then h, the perpendicular height, is what? H, the perpendicular height, is what? 8 seconds. So that gives us what? That gives us half times 90 meters per second times 8 seconds. Second, we cancel second. That's 90 meters times 4. That's what? 360 meters. So you can always use any of these two to calculate your distance traveled. Either you use the formula or you use the area under the graph. You will always get the same answer. So let's keep practicing. 13. Question 13 now. A body starts from rest and accelerates uniformly at 8 meters per second squared. Calculate the time taken. A body starts from rest and accelerates uniformly at 8 meters per second square. Calculate the time taken by the body to cover a distance of 1 kilometer. Okay, let me draw a velocity time graph straight. Okay, just to learn it. We are not asked to do it, but just to learn. Okay, velocity meters per second starts from rest and accelerates uniformly at what? 8 meters per second squared. Calculate the time taken. Okay, let's draw this down. We are looking for time taken to cover a distance of 1 kilometer. Okay, that's pretty simple. Rest means that the initial velocity is 0 meters per second. We need the time taken to accelerate at 8 meters per second squared and cover a distance of 1 kilometer. 1 kilometer is not SI unit of meters, so we need to change it to SI unit. So that means our distance is 1000 meters. So using S is UT plus half AT squared. What do I get? 1000 is equal to 0 times T plus what? Half times 8 times T squared. Half times 8 times T squared. That gives us, okay, I didn't write this one. It should be 1000. Not 100. That gives us 1000 is half times 8t squared. That's 4t squared is what? 1000. So what does that give you? That says 4t, okay, 4t squared is 1000. T squared is 1000 over 4. So t squared is what? 250. T is square root of 250. Square root of 250 is what? Square root of 250. You put it yourself in seconds. That's how long it will take the body to cover a distance of 1 kilometer, starting from rest and accelerating at 8 meters per second squared. Let's go to 14. A particle starts from rest and moves with a constant acceleration of 1.5 meters per second squared. The distance covered in 15 seconds is starts from rest, U is 0 meters per second. Acceleration 1.5 meters per second squared. Distance covered in 15 seconds. So we know the time, but we don't know the distance. Using S is UT plus half AT squared. I'm still going to draw the graph. I'm taking this formula, S is UT plus half AT squared, because all I have in my equation is A, U, T, and S. So those are the 4 quantities I have. So I'll choose the equation that connects those 4 quantities. So what will I do? I'll get S is 0 times 15 plus half AT squared. That's half times 1.5 times what? 15 squared. That gives us half times 1.5 times 15 squared, which is what? Distance traveled is half times 1.5 times 15 times 15. So you press your calculator, you get your answer in meters. So that's question 14. Question 15 now. Okay, I said I was going to draw a graph. Let me draw a graph for question 14. Time in seconds. Velocity in meters per second. So what's this going to give us? Let's put it together. 0, okay, time 15 seconds, acceleration 1.5 meter per second squared. Then the distance traveled. We want the distance traveled. Okay, no, we have the distance. Okay, we don't have the distance. It's distance we don't have. So distance question mark and U. So how we did it to get our answer. The initial velocity was 0 meters per second. Let's go to number 15. Let's go to question 15. What do we have in question 15? These are all simple questions. Every time it pops up, you should not run away. A body accelerates uniformly from rest at 10 meters per second squared. Calculate from rest at 10 meters per second squared. Calculate how long it takes. Calculate its velocity. Okay, calculate its velocity after traveling a distance of what? Of 35 meters. After traveling a distance of 35 meters. That's simple. Accelerate from rest 0 meters per second with an acceleration. Okay, moves from rest with an acceleration of what? 10 meters per second squared. Then it says calculate its velocity. Here we don't have any business with time. We need the final velocity after traveling a distance of 35 meters. So what formula connects U, A, V, and S? That's the formula we need for this question. We will call on the fourth equation of motion. So we say using V squared is equal to U squared plus 2AS. Using V squared is U squared plus 2AS. That gives us what? V squared is equal to what? U squared, that's 0 squared plus 2 times 10, which is the acceleration, times 35. So V squared is 0 plus what? 700. So V squared is 700. That means our final velocity is the square root of 700. Square root of 700 is square root of 7 times 100. That's root 7 times root 100. That's what? 10 root 7 meters per second. Our velocity attained after traveling, the velocity it attains after traveling a distance of 35 meters is what? 10 root 7 meters per second. Let's go to question 16. We're almost done. A body moving with a velocity of 4 meters per second is brought to rest by a constant force after traveling a distance of 60 meters. Calculate its retardation. Okay, that's pretty simple. Initial velocity 4 meters per second. We don't know the deceleration, but we know that it traveled a distance of 60 meters before coming to rest. So the final velocity here is rest. Can you see how our English is turned into values? The final velocity attained in the motion of the body is that it came to rest, and rest means the velocity is 0 meters per second. So let's go. What is the acceleration? So here, what formula connects U, V, A, and S? Because these are the four quantities we have: U, A, S, and what? V. What formula connects U, A, S, and V? It is V squared is equal to U squared plus 2AS. But in this case, we know our V, 0 squared. We know our U also, 4 squared. 2 times A, we don't know A, but we know distance, 60 meters. So 0 is equal to 16 plus what? 120A. How do we do this? Very easy. Bring 120A to the left. 0 minus 120A is equal to 16. So minus 120A is 16. A is 16 over minus 120. What does that give you? 16 divided by minus 120 means A is minus so and so meters per second square. You pretty want to evaluate yourself, I think. That's okay right there. Number 17. Question 17 says, a car moving with a speed of, okay, I didn't draw velocity time graph for question 16. Let's draw a velocity time graph for question 16. Can you just pay attention? Time in seconds, velocity in meters per second. It was initially moving at 4 meters per second, then decelerated to rest. So this is the initial velocity. Then final velocity is 0, because this axis shows that it starts from 0 there. So, and everything happened. We are looking for acceleration, we don't know it. That was what we got here. That's what you will get here after dividing. So it will be a negative deceleration. So don't let me put question mark again because we found it. Then distance traveled is what? 60 meters. That one too is given. So that's the velocity time graph for that question. Number 17 says a car moving with a speed of 270 kilometers per hour was brought to rest by the application of the brakes in 20 seconds. How far did it travel? Okay, it was initially moving, the car was initially moving with a speed, let's draw velocity time graph, velocity in meters per second. It was initially moving with a speed of what? So that means u was 270, u was initially 270 kilometers per hour. Let's change 270 to meters per second. That's 270 times 5 over 18. Okay, 270 times 5 over 18. What does that give you? 270 times 5 over 18. That's 75. So the initial velocity was 75 meters per second. I'll just mark this place, 75. Decelerated to rest. Said it decelerated to rest in 20 seconds. It decelerated to rest in what? 20 seconds. So we should find the distance traveled after the brakes were applied. So in this case, what we don't know is the what? Distance. So we know the initial velocity, we know the final, which is 0, and we know the time, which is 20. So let's jot down values and see which formula will help. So distance traveled, okay, we know it. No, we don't know the distance traveled. It is the distance traveled we are looking for. So distance traveled, we don't know it. Initial velocity, 75 meters per second. I think I need to space this small. Sorry, I'm just... Okay, distance traveled, question mark. Initial velocity is 75 meters per second. Time taken to decelerate, 20 seconds. Final velocity, 0 meters per second, because it came to rest finally. Now we need to use a formula connecting S, U, V, and T to find our S. If you inspect very well, if you inspect your equations of motion, you will see that the one that fits this, task is S is average velocity. Distance traveled is average velocity times time. So that distance traveled is U plus V over 2 times time. Distance traveled will now be what? 75 plus 0 over 2 times what? 20. So that's what? 75 over 2. 75 is in meters per second times 20 seconds. So put this together. Seconds will divide seconds. What do you get? Seconds will divide seconds. Seconds will divide seconds. What do you get? Seconds will divide seconds. There's no second there again. So you'll be left with 75 over 2 times 20. 75 over 2 times 20. This is in meters. This is in meters. So that gives you what? 75 meters times 10 times 10. So that's what? 750 meters. So distance traveled after the brakes were applied before getting to rest is what? 750 meters. Last question now. Number 18. Last question. Number 18. Number 18 says, an aeroplane lands on a runway at a speed of 342 kilometers per hour. Say, what distance does it travel on the runway before coming to rest? 342.24. It came to rest. It landed with an initial velocity of 342 kilometers per hour and came to rest in a time of 24 seconds. We need the distance traveled before coming to rest. So final velocity was rest, which is what? 0 meters per second. So now, this is pretty simple. We can draw a velocity time graph that will have this picture, velocity time graph, that we have this picture, v in meters per second, landed with 342 and decelerated to rest. The time of deceleration is given as what? 24 seconds. So first thing we need to do here is change 342. The initial velocity is 342 kilometers per hour. Let's change it to meters per second by multiplying it by 5/18. What does that give us? That gives us u is 342 times 5/18. That's 95. So that's 95 meters per second. So 95 meters per second. So 95 meters per second. What does that mean? Okay, what do we need here? The question says we should find the distance traveled. Distance traveled is the area under the graph. That's why I always write the distance traveled in a velocity time graph is the area under the graph. That's why I always put S right here. So don't be scared. So here now, what formula connects? Look at the quantities we have. We have U. Okay, let's say this is our new U, and that's what we will use. We have T, we have U, we have V, which is rest 0, and we are looking for S. What formula connects these four? U, V, S, and T. The formula connecting those four is S is equal to UT plus half AT squared. So we say using S is UT plus half AT squared. No. There's no A. So no. There's no A. The formula connecting all four is S is U plus V. S is U plus V over 2 times T. We only have T, U. We only have T, U, V, and S. So the formula we will use is S is equal to U plus V over 2 times T. So S will be 95 plus 0 over 2 times what? 24. So put everything together. 95 is 95 meters per second over 2. This is my initial velocity. This is the final. You understand? So that's 95 over 2 meters per second times time 24 seconds. If you do your math well, you understand 2 will cut 24. You have 95 meters per second times 12 seconds. Here too, S will cut S. What do you get? You get 95 meters times 12. What's 95 meters per times 12? That's your distance. You press your calculator yourself. You press your calculator yourself to get the final answer. I'm going to send an exercise to you to, exercise your muscle on this.